Welcome back to the ChemDoctor, and this is the fifth video in the series on gases. And the concept that I want to deal with this morning is the concept of what's called molar volume. And for a gas, this concept is very important because the concept can be used to solve a lot of different kinds of problems, not the least of which is being able to determine, for example, the molar mass of an unknown gas, or to determine the density of a gas or an unknown gas. Now, it all begins with understanding the concept of molar volume. All right, and like molar mass, molar volume is literally the volume of exactly 1 mole of gas at specified conditions. So in other words, the volume of 1 mole of gas at fixed or constant temperature and pressure. And in the case of chemistry, we are going to stipulate specific conditions for this. So the first thing we're going to do is stipulate what's called STP. And STP is standard temperature and pressure. All right, so in the definition of molar volume, what I specify here is that we're going to determine the volume of exactly 1 mole of gas under conditions of constant temperature and pressure. So what we're doing here is we're going to stipulate what the temperature, the standard temperature and pressure for a gas. So in this case, STP in chemistry will be conditions of temperature where we're at either 0 degrees centigrade or 273 Kelvin, because remember in gases that essentially all of our calculations need to be done in absolute temperature. And we're going to stipulate the standard pressure being at 1 atm, which in general is the standard air pressure at sea level. So stipulation number 1 is that we're going to define STP being at 273 Kelvin and 1 atmosphere pressure. For molar volume, this is going to be the volume of a gas at exactly 1 mole. So we're going to further stipulate that we're dealing with exactly 1 mole of gas. All right, and in the third step here, which this is pretty simple when it boils down to it, we're going to use PV is equal to nRT to calculate the molar volume. All right, so solving the equation for volume, V is going to equal nRT over the pressure. And now we can go ahead and we can plug in. So the moles will be exactly 1 mole as stipulated. The gas constant is 0.0821, okay, and then look at your units, liters times atmospheres divided by mole times Kelvin. All right, our temperature is at 273 Kelvin. And we're going to divide the whole shebang by 1 atm. All right, and if you look closely here, you can see what the units do. Moles cancels with moles. Kelvin with Kelvin. Atmospheres with atmospheres. And we have successfully solved for liters. And what we see is that the volume of a gas, the volume of 1 mole of gas at STP is equal to 22.41 liters. All right, now we can define basically here a unit conversion factor where under conditions of STP, fixed temperature and pressure at 273 Kelvin and 1 atm of pressure, we can stipulate that 1 mole of a gas is 22.41 liters. This is a very important unit conversion factor because we can use it to do all kinds of different calculations for gases as long as we are under the stipulated conditions of STP. Note, before I close the video, and we're going to move on to do an example, that we could also determine the molar volume of a gas if we want to at a different set of conditions of not STP, but what I mean is a different set of conditions of temperature and pressure. So if we were not at STP, we were at a different fixed temperature and a different fixed pressure. We could find the same kind of quantity here and then utilize that quantity to do calculations under those specified conditions. All right, so with this, I'm going to go ahead and close this video.